I'm going to share my screen. And as I do that, I realize I just let somebody into class and I have to apologize. I can't remember who it was. Who just entered class so I can get you on attendance? Angela M., was it you? There she is. Yes, it was. Okay, she's in. Okay, before we get started with the notes, at the beginning of class, I was just, that's not you. This one's you. Today we're going to start looking at other types of equations and possibly inequalities. Homework 1.5, of which is the homework on solving quadratics, is due today. Homework 1.6 won't be due until Monday. There's several other types of equations that we have to look at. And then the next homework 1.7 also is more than one day's worth of notes. And so that's a little bit later. That'll be the end of this unit, and we'll be talking about a unit test soon after that. Just because we spent a bit of time on quadratics, I'd like to give a quiz on quadratics. I have not yet typed it, but there will be a quadratic quiz. It'll be available after class Friday, and it will be due by the end of Sunday. It'll probably be about 20 minutes. It'll probably be maybe 4 quadratic equations that you're asked to solve, one by factoring, one by completing the square, one using the square root property, and one using the formula. And because I want you to actually use those methods, you must submit your work in Blackboard. When I put the quiz together before Friday, I will have that Dropbox open in Blackboard. Before I do that though, before we get started, how is everybody doing with that homework, with those quadratic equations? Does anybody want to look at anything from homework 1.5 or anything from any of the homeworks before that, anything from this chapter?
Can we look at number 20?
In homework 1.5?
Yeah.
Okay. And sometimes I feel like I'm begging you guys to ask questions. Honestly, in on-campus classes, I usually spend about 15 to 20 minutes kind of just, whoa, something happened. Trying to just go over problems from the homework that people might have questions with. So don't ever, if I forget to say that at the beginning of class, wow, I'm going to go someplace else and then head back. That hasn't happened to me in a while. You know what? Let me go all the way out and all the way back. And rather than going through the assignment manager, let me just go in through the list of homeworks. So let me go to homework. And let me look at that homework 1.5. And question number, which one? How full question were we looking at? Was it 20?
Yeah, number 20.
Okay. And so please notice when you guys get weird things from Pearson and it doesn't let you work for a while, it happens to me too sometimes. And I find that usually give it 5 minutes and go back and it works fine. Also, if you ever have problems with Pearson, I also find that if I go through, or Blackboard, if I go through and clear my, I can't say it, cache or cache, I don't know how they say it. Usually it makes things work better. So solve the following by completing the square. I know immediately what your issue is. We're trying to solve by completing the square. This equation, x squared minus x minus 1 equals 0. We said completing the square, the first thing we do is we want to get their constant terms alone. So that gives me x squared minus x plus something equals 1. And we have to decide what that thing is. And in order to decide what that thing is, remember we looked at this coefficient and give me a second, I'm going to erase that and try to make it look better. Put a little bit of space. This coefficient and that coefficient is -1. We said we were going to take that coefficient, divide it by 2, and square it. And I'm thinking that the problem arises is it's unsettling when that gives you a fraction. That gives me the fraction 1/4. So I'm going to add 1/4 to both sides. That gives me x squared minus x plus 1/4 equals, rather than doing 1 and 1/4, I'm going to use that improper fraction 5/4. Is that where the biggest difficulty was in dealing with that fraction? Then I think the next problem is, well, if that's the fraction, how in God's name do I factor that? And in terms of factoring, that's going to be x. We know that middle term is going to be a minus. And that last number always turns out to be what I squared. So that's x minus 1/2 on the square. So now when I use the square root property and I take the square root of both sides, I get x minus 1/2 is equal to plus or minus the square root of 5/4. And with that, remember when we take the square root of a fraction, we take the square root of the numerator, which is plus or minus 5, over the square root of the denominator, and the square root of 4 is 2. So that gives me x minus 1/2 is equal to plus or minus the square root of 5 over 2. And so when I add 1/2 to both sides, I get x equals 1. They have a common, I'm running out of room here. I get x equals, well, when I add that 1/2, they've already got the common denominator. So I'll have 1 plus the square root of 5 over 2. And then the other one, I'll have 1 minus the square root of 5 over 2. Any better?
Yeah, that's a little bit better.
And am I correct in assuming that what made that one harder than the other completing the square questions was because we have that fraction? And please realize that whenever this middle term has an odd coefficient, we will have a fraction. So I will try my darndest not to put a fraction 1 on a test or quiz, but I would feel like I did you guys a disservice if I didn't put at least one that involves a fraction in the homework. So.
Thank
Can you
you.
go over number 7?
Sure. I keep forgetting that I have to turn my finger back into a mouse in order to do that. Number 7.
Yeah.
Asks you to solve the equation using that square root property. And so this is actually kind of like when we were completing the square. At one point in time, we had x minus 3 squared is equal to a number. Square root property says that if I have a square equaling a constant, I can take the square root of both sides. On that left, that gives me x minus 3. On the right, when I take the square root of a constant, I have to remember there's 2 of them, a positive 1 and a negative 1. And so that gives me x minus 3 equals positive 3, or x minus 3 equals negative 3. So far, so good. And so now when I solve it, I'll add 3 to both sides. And one solution is 6. And then again, I'm going to, on the other side, add 3 to both sides. And that gives me my other solution is 0. So my 2 possible solutions are 6 and 0. Better?
Yes, thank you.
Can you go over 28?
Sure. If I can find it in this list. There we go, 28. the equation by the method of your choice. Okay, so I have 1 over x plus 1 over x plus 2 equals 1/4. Hey folks, this brings me to that last quiz. There was a question that I was surprised a lot of people didn't do real well on. With a question like this, because I've got variables in the denominator, I have to worry about where it's undefined. And I'm going to find those undefined places by setting the denominators equal to 0. I apologize. It would help if sometimes when I talk and write at the same time, my hand doesn't agree with me. The second denominator is x plus 2 equals, and when I set that denominator equal to 0, I get -2. So I know before I solve the problem that 0 and -2 cannot be answers. Next, because this is a fractional equation, I find it easiest if I get rid of the fractions before I begin. And so my lowest common denominator, I have 3 different denominators and they have nothing in common between them factor-wise. So I'm going to just multiply and get 4x times x plus 2. Now, the reason I can use this to get rid of the reason I can use this to clear the denominators is because I'm going to multiply both sides by the same thing. And again, I can do that because by clarifying where it's undefined, I'm going to kind of mentally make sure I'm not multiplying both sides by 0. Does everybody see on the left-hand side the need to distribute? So that gives me 4x times x plus 2 times 1 over x plus 4x times x plus 2 times 1 over x plus 2 equals 1/4 times 4x times x plus 2. And that, I find that step a pain in the ass because it's kind of just rewriting it, but I think it's worth rewriting it because then I can see what cancels out when I multiply. So here I have 4 times x plus 2, which would be 4x plus 8. Plus here, I get 4x equals, and then on the other side, the 4's cancel out, and I get x times x plus 2, which would be x squared plus 2x. So that gives me 8x plus 8 equals x squared plus 2x. And now I've got that quadratic equation. So when I go to solve that, x squared plus 2x equals 8x plus 8. When they say using the method of your choice, they mean, hey, do you want to factor? Do you want to complete the square? Do you want to use the square root property? Or do you want to use a quadratic formula? Before I make that decision, I'm going to put it in standard form by subtracting 8x and 8 from both sides. So that gives me x squared minus 6x plus 8 equals 0. Well, I think that one's a pretty easy factor. X squared would be x and x. My signs are the same, both negatives. Multiplying to 8 would give me, let's see, 2 and 4. And so that gives me setting x minus 2 equals 0. X equals 2, setting x minus 4 equals 0. X equals 4. Neither of them are values that I have to exclude, so my solutions are 2 and 4. Is that any better?
Yes, thank you.
Okay. Was it that it started with fractions and that you were like, wait a minute, this doesn't look like a quadratic equation. What's going on here? I think the preceding assignment, we worked with fractional equations. And so even though this isn't the fractional equation, a homework assignment, that's something you're expected to be able to recognize and apply from this time forward, okay? Anybody want to look at any others?
I'm stuck on 29.
Okay. And is everybody all right if we make 29 the last homework that we look at? Find all of the values. Oh, and are you stuck? Let me get my Gooby Gone out. Are you stuck? Because this has two variables, y equals negative 2x squared plus 3x. But we want to know what happens when y equals negative 2. So what we're going to do is we're going to substitute negative 2 in for y. And now we've got a quadratic equation in one variable. I want to make one side 0. And this one, I'm going to do something that some people might think counterintuitive. I hate it. Don't let anybody hear this. I hate it. I think it's ugly when my leading coefficient is negative. So to avoid that, I'm going to make that right hand side 0. And so that gives me 2x squared minus 3x minus 2 equals 0. Then from there, it's a matter of personal preference. Do you want to factor, complete the square, use the quadratic formula, or use the square root property? I'm old school, and so I'm thinking that this one is factorable. If I have 2x and x, one's a plus, one's a minus. And if I put the 2 in here, when I FOIL, 2x times minus 2 would give me minus 4x in the middle. If I put the positive 1 there, minus 4x plus 1x gives me that negative 3x in the middle. So I factored it right. And so now when I set each factor equal to 0, we'll do the hard one first. Adding 2, I get x equals 2. And then doing the other one, I'm going to have to subtract 1. 2x equals negative 1, and then divide by 2. And so, I've run out of room again. I get x equals negative 1/2. Did that clarify what you were wondering about?
Yeah, I got it now.
Was it just the, oh my God, there's two variables in here. What the hell do they want me to do with it? They give you a bit.
Yeah, I was used to them telling me to do the equation first, then solve it, but I think I just read it wrong because it's asking for the solution set. So I think I just read what it was asking me. I kept putting in the equation.
Solution set is just kind of a like a cautionary tale. I might have more than one answer.
Okay.
And usually, remember we had said if you have a second degree equation, you should expect 2 answers. It's rare that you will only get 1. Okay. All right. So let's see. When we finished last class, oh my heavens, my desk is a mess. I have books piled on top of books, piled on top of books. When we finished last class, we had finished looking at solving higher degree equations, and we had said that we were going to solve those by factoring and setting each factor equal to 0. So we had finished off last class with higher degree equations. And again, our method for those, our approach was to make one side 0. Factor completely. Set each factor to 0. Solve the resulting equations. And because there's frequently a lot of work involved with those, with this one, it's really strongly recommended that you check. And if I remember correctly, when we're going through the examples last class, nobody seemed to have an issue with those. Those are the questions at the beginning of homework 1.6. After you look at those higher degree equations, The next equations that you're going to look at are radical equations. And when we call something a radical equation, it's an equation with a variable in the radicand, or with a variable under the radical. And so if we look at an example, let's say I have 3 times the square root of 20 minus 8x minus 3x equals 0. How fun does that look? In order to solve an equation that looks like this, the first thing that we want to do is isolate the radical. We want to get the square root all alone on one side of the equation. So we're going to have the square root all alone and everything else over on the other side. So here, to get my radical alone, does it make sense? We'll add 3x to both sides, giving me 3 times the square root of 20 minus 8x is equal to 3x. It's almost all by itself. I think we still need to divide both sides by 3, which gives me the square root of 20 minus 8x is equal to x. Now that we've got the square root alone, what can we do? What's the opposite of taking the square root? What can we do to undo taking the square root? Any ideas? We're going to square both sides. Again, the idea that whatever you do to one side of an equation, you have to do to the other. So I'm going to take that square root of 20 minus 8x and square it. And then on the other side, I'm going to take that x and square it. Be careful though, because our properties of equality say we can add the same thing to both sides. We can multiply the same thing to both sides. When you start doing things like squaring both sides, you kind of get into a gray area. And so because of this step, there is a chance that we might get what's called extraneous roots, roots that work for our derived equation, but not our original equation. And so with these, checks are mandatory. But I digress. When I square a square root, don't I just get the radicand, take the hat off? And when I square x, I get x squared. Now that equation looks like we should be able to solve it. We've definitely got a quadratic. In order to solve this, let's first put it in standard form, making one side 0. And again, this time I'm going to make the left-hand side 0 because I want to keep my x squared positive. Gives me 0 equals x squared plus 8x minus 20. And we've got one of those quadratics. How would you folks go about solving it? Would you factor this one? Would you use the square root property?
It's easily factored.
Beautiful. And I know some people just never find factoring easily. And if you're one of those people who never finds factoring easy, realize I think it's a lot more work, but you can always use your quadratic formula if you're really adverse to factoring. But again, I think this one factors pretty easily. And so now to solve that, when I set each factor equal to 0 and solve the resulting equations, I get x equals -10 or x equals 2. And again, we've got these two solutions, but we're not sure they both work. So with these, it's always important to check in the original. There might be extraneous roots. So we could have done everything right, but still get a solution that doesn't work for our original problem. And so scrolling up, our original equation was, whoops, 3 times the square root of 20 minus 8x minus 3x equals 0. And so first, if x equals -10, that gives me 3 times the square root of 20 minus 8 times -10 minus 3 times -10 has to equal 0. And that gives me 3 times the square root of 100
100.
plus 30, which gives me 30
Plus
plus
30.
30. 30 plus 30 equals 0, doesn't it?
No.
No. And so we're going to reject this as a solution. While it worked for our derived equation, it doesn't work for our original equation. So now let's keep our fingers and toes crossed and see if that x equals 2 works. So that becomes 3 times the square root of 20 minus 8 times 2 minus 3 times 2. Does that equal 0? Let's see, 20 minus 8 is 4. 3 times 2 is 6. The square root of 4 is 2. So 6 minus 6, does that equal 0?
Yes.
And so we only have one solution. And so do you see how with these, it's important to check? Because again, going way back here, when I square both sides, I'm again not real sure what I'm multiplying both sides by. And so it gives me the possibility of getting those extraneous roots. All right?
Can you just hold here for a minute?
Sure. Let me know when you're ready to turn pages. Because we're going to do a couple more of these. And then, yay, we're going to look at equations that have fractions and the exponents. Woohoo, what fun.
All right, I'm done. Thank you.
Okay. So another example. Let's say I have x minus the square root of x plus 11 is equal to 1. First thing we want to do is get the square root alone. So let me subtract x from both sides. Gives me the negative square root of x plus 11 is equal to negative x plus 1. Not quite all alone, so let's go through and divide both sides by -1. Gives me the square root of x plus 11 equals x minus 1. Is everybody all right up to there? Solving the equation for the square root.
Yes.
Now what do we have to do?
You have to square both sides.
And when I square both sides, on the left, when I square a radical, I just get the radicand. They're inverse operations. They do opposite things. The squaring undoes the square root. And on the right, when I take x minus 1 and square it, realize that means either I have to remember that pattern that we talked about in completing the square, or I have to FOIL it out by itself. Gives me x squared minus 2x plus 1 when all is said and done. Now, we've got a quadratic equation. Since we have a quadratic equation, the second degree equation, I want to put it in standard form, which means I want to make one side 0. So I'll subtract the x and the 11 from both sides. And that gives me 0 equals x squared minus 3x minus 10. And again, to solve that, you have a whole bunch of things, tricks up your sleeves. Factor, square root property, complete the square, or the quadratic formula. But again, I think this one's a pretty easy factor. Again, though, if you're one of those people in the world who would do anything rather than factor, you can use the quadratic formula. But that 10, I'm going to think of it as minus 5 plus 2. And when I FOIL that back out, it would give me that negative 3 in the middle. And so now, since that product has to equal 0, one of those two must be 0. And so adding 5 to both sides, I can get x equals 5. Or subtracting 2 from both sides, I can get x equals negative 2. And please realize, no matter how confident you are in what you did, we're not positive that they both work. So we want to go back to that original equation, which was x minus the square root of x plus 11 is equal to 1. And so checking when x equals 5, that gives me 5 minus the square root of 5 plus 11, or 5 minus the square root of 16, or 5 minus 4 equals 1. So I'm happy. But let's check that other one. If x is negative 2, that gives me negative 2 minus the square root of negative 2 plus 11. Gives me negative 2 minus the square root of 9. Gives me negative 2 minus 3, which is negative 5. And does negative 5 equal 1? I
No,
don't think so. So this one we're going to have to reject. And so our answer is x equals 5. And so you'll have a couple like this in the homework. And I think the next example that we're going to do, there's only one of them, I believe, in the homework, if I remember correctly. But I want to tell you that this next problem is going to be a little bit more involved than you expect. Is everybody all right if I turn the page?
Yes.
Next one, I've got the square root of x plus 5 minus the square root of x minus 3 equals 2. And please notice what makes this one different is that it's got 2 radicals. And if you have 2 radicals, what happens is you have to square twice. Because right now, if I were to square this by itself, I can think of that as being a binomial. And so when I square that, I'd still have a radical left in the middle. And that becomes annoying. And so with these, if you have two radicals, what you want to do first is just isolate one of the radicals. We want to get one of them alone. So here, because the first one's positive, I'm going to get that alone. And so I'm going to add the other radical to both sides. And it gives me the square root of x plus 5 equals the square root of x minus 3 plus 2. Next step, what we have to do is carefully square both sides. Usually I just put the exponent on either side, but because I want to see everybody to see that this is like a separate step, I'm going to go through it. I'm going to rewrite it with the exponent on either side. And the left-hand side's pretty straightforward. When I square a radical, I just get what's underneath. But on the right-hand side, when I square that thing, I have to think of either using that pattern for squaring a binomial that we discovered as we completed the square, or I have to take that thing and multiply it by itself twice. I'm going to go through and multiply it by itself twice. Or, yeah, let's multiply it out. First, when I take the square root times itself, I just get what's underneath the radical. Outer, I get 2 times the radical. Inner, I'd also get 2 times the radical. And last, I'd get 2 times 2 or 4. So this gives me x plus 5 equals, let's see, x minus 3 plus 4 would be x plus 1. And then 2 times the radical plus 2 times the radical is 4 times the radical. Wow. Now what we want to do is isolate the remaining radical. Get that square root that's left alone. So let's subtract x and subtract 1 from both sides, giving me 4 equals 4 times the square root of x minus 3. Not quite all alone. Let's divide both sides by that 4. And get 1 equals the square root of x minus 3. And that was all so much fun. Let's go through and square it again. One squared is long. But the square radical, I just get what's underneath, x minus 3. And finally, we've got something that's pretty straightforward to solve. I'll add 3 on both sides and get x equals 4. And I don't think that any one step is that difficult. But just the fact that you have to go through and do that squaring twice makes it a little bit tedious. Remember, if you have two square roots, you've got to go through and square it a second time. After doing all of that work, does it make sense that we probably need to do a check to make sure we did it all right? And again, we're always going to check in the original equation. So backtracking, the original equation was the square root of x plus 5 minus the square root of x minus 3. We're hoping that equals 2. So the square root of, we said x is 4 plus 5 minus the square root of, again, x is 4 minus 3. What does that give us? That gives us the square root of 9 minus the square root of 1. 4, 3 minus 1 equals 2. Yay, we did it. What do you think? We good?
Yeah.
Okay, I have to tell you guys for just a minute, I had a heart attack because I looked in the room that I'm in is the office in our upstairs. And I looked at the time on an old digital device and the clock is wrong. And so I thought, oh my God, class is over. No, we still have more to do. But class isn't over. I was reading the clock wrong. So everybody okay with that?
Yeah, I'm good.
Okay. If those are all right, again, you only have one with 2 radicals in the homework. You have a couple though with 1 radical in the homework. Remember, get that radical alone. Square both sides and make sure you do your check. The check's real important with those. Then the next thing we're going to look at are equations with rational exponents. And so, first example, let's look at x to the 3 halves plus 3 equals 30. And does everybody remember earlier in the semester, we defined those fractional exponents. And we had said that if we had an exponent that was a fraction, it means we've got a radical. But we're going to find with these, it's actually easiest to leave it as that fractional exponent to start. The first thing that we want to do is we want to isolate the factor, the part of the equation, the term, with the rational exponent. And looking at this equation, does it make sense that the only thing that has that fractional exponent on it is that x? And so I want to try to get that x alone. Everybody all right with subtracting 3 from both sides? Which gives me x to the 3 halves equals 27. Now, what I want you to remember, we're going to do a little scrapbook in the middle. Do you remember that if I raise a power to a power, I multiply exponents. And do you remember that if I multiply something by its reciprocal, I get 1. And so putting those two facts together, what we're going to do now is we're going to raise both sides of the equation to the reciprocal power. And I want to say that when you first do this, I agree with you, it looks a little ugly, but magic stuff happens. When I take that x to the 3/2, the reciprocal of 3/2 is 2/3. And on the other side, I get 27 to the 2/3. And again, like we said in the scrap work off to the side, when I raise a power to a power, I multiply those exponents. And when I multiply something by its reciprocal, I get 1. And so that leaves me with x to the first. So now we're going to simplify and solve. And now here on the other side, when I take x to the 2/3, if you're real good with the parentheses keys on your calculator, you can get this result from your calculator. Otherwise, doing it by hand. Does everybody remember that if I have a fraction in the exponent, it means I'm taking a radical? The denominator of the fraction becomes the index. The numerator of the fraction becomes an exponent. And the base becomes my radicand. So the cube root of 27 is 3. And when I square 3, I get 9. And again, because I was raising both sides to a power, with these, it's equally important to check. And when you check, you always go back to the original, because sometimes we can get a solution that works in our derived equation that wouldn't work in our original equation. And our original equation was x to the 3/2 plus 3 has to equal 30. So I'm going to look at 9 to the 3/2. Whoops, I wrote 0 instead of 30. I apologize. 9 to the 3/2 plus 3. Well, 9 to the 3/2 is the square root of 9 cubed. So that's 3 cubed, or 27. And when I take 27 plus 3, do I get 30? Woohoo, it checks.
I have a question.
Sure.
Where did the 2 go? The 3/2. You only used the 3, it looks like.
Because when the 2 would be the index on the radical. And when I take the second root of 9, it's just taking the square root. So that the second root of 9 is just the square root of 9. If you want to write that 2 in there, you can, but you don't have to. I think I told you guys once, my theory is that mathematicians are intrinsically lazy and don't like to write. And so that's a shortcut I can take.
Okay, thank you.
Okay. Should we try another one? Can I turn the page? Are you guys ready or not?
Yeah, go
I'm
ahead.
ready.
So next example. Let's look at x plus 5 to the 2/3 minus 4 equals 0. And notice with this one, there's more than just a single variable being raised to the power. We said that we wanted to get that part that's being raised to a fractional power alone. And so I'm going to add 4 to both sides. Is that a sensible first move to everybody? And I get x plus 5 to the 2/3 equals 4. Now, because all of this is in the parentheses, I want to get that out of the parentheses by undoing that exponent. And so even though it's more than just a single variable, I want to raise both sides to the reciprocal power. When I raise a power to a power, I multiply those exponents. So that gives me x plus 5 to the first, which is just x plus 5. And the other side, 4 to the 3/2 is the second root of 4 cubed. The square root of 4 is 2 cubed is 8. And now, to solve that, we'll subtract 5 from both sides and get x equals 3. So for my check, I have to go back to x plus 5 to the 2/3 minus 4 equals 0 and put in 3 for x. So just 3 plus 5 to the 2/3 minus 4 equals 0. 3 plus 5 is 8 to the 2/3. We'll keep it minus 4. Let's see, 8 to the 2/3. I've got a fractional exponent. I'm going to draw a radical. The denominator becomes the index. The numerator becomes an exponent. The cube root of 8 is 2. 2 squared is 4. And so we've got there is 4 minus 4, which equals 0. And it checks. And again, in order to do these, you have to be all right. You have to be able to memorize, not memorize, remember what we had said before. Is everybody comfortable with this idea that when I have a fractional exponent, I need to change it into a radical? Does everybody remember all of that?
Yep.
Okay. Any questions? If not, there's one last type of equation that's in this section 1.6. And can I turn the page? Those are going to be equations that are, and we'll put this in quotes, quadratic in nature. And so we're going to go through and take what we did in the preceding section, solving quadratics, and apply them to equations that when you first look at them, you might not think they're quadratic, but we can gently massage them to make them quadratic. So first, let's remember what a quadratic equation is. If I have a general quadratic, it's something of the form ax squared plus bx plus c equals 0. And we had said that a, b, and c are real numbers. And when I compare the x squared to the x, you notice that because it's squared, we can say that the exponent on the leading term is double the exponent on the middle term. And the constant has no variable. So we're going to look for equations that have that pattern, but maybe don't quite have that x squared. So let's look at example at 4x to the 4th minus 13x squared plus 9 equals 0. And again, in order to use this, we want one sign 0. And we want descending order. And now I want to compare it to my, I guess I'm going to change the x to, I'm going to use a different variable. AU squared plus BU plus C equals 0. And you notice it fits that pattern. I have a trinomial. I have real coefficients. Last term is a constant. And well, these are higher exponents. Do you notice that one exponent is double the other? So what we're going to do is we're going to substitute. I like to call it a dummy variable. And we're going to, usually they use that letter U. We're going to let U equal the variable part of the middle term. So I'm going to say U is equal to x squared. And if U is equal to x squared, wouldn't U squared be x squared squared or x to the fourth? So we're going to replace x to the fourth with u squared. We're going to replace x with u. And now that gives me a quadratic to solve. Now, I think that one's pretty factorable. In order to get that 13 in the middle, I think if I have 4u and u, that will give me my 4u squared. My signs are both negative. And for the 13 in the middle, I think if I use 9 and 1, when I multiply this out, I'd have minus 4u minus 9u. That would give me that minus 13u in the middle. For product to be 0, one of the two factors must be 0. So that gives me 4u equals 9, and u is 9/4. And over here I get u equals 1. And before I stop and get myself on the back, I have to remember, hey, wait a minute though. That was not the question I had to solve. I wasn't looking for u. I was looking for x. So now we're going to back substitute. The original variable. What happened there? So u was x squared. So I get x squared equals 4. X squared equals 1. And now I'm going to solve. So taking the root of both sides, I get x equals, remember there's two roots, plus or minus the square root of 9/4. And here x equals plus or minus the square root of 1. And so positive root would be 3/4. Negative root would be negative 3/4. Positive root here would be 1. Negative root here would be negative 1. And I get my 4 distinct answers for an equation that's e raised to the 4th power. I'd like to do another that looks a little bit different, but I'm looking at the clock and thinking that we've done a lot. And to race through another one in 4 minutes, I don't think really is doing you a favor. And so let's stop here, quick backtrack. Does everybody notice how this one isn't quite quadratic because it's 4th power, but it's got that trinomial descending order where one exponent is half the other. That's when I know that I'm going to use this idea of u substitution, putting in another variable for the x squared, which then turns it into a quadratic that I can then solve. But then I have to go back and remember what u was supposed to represent and solve for the original variable. We'll look at another one of these on Friday. Does anybody have a question on that or anything that we've done today? Can I stop sharing? And we did cover a lot of work. We will pick up from here Friday. If you have any questions, please shoot me an email. Otherwise, if you want to talk to me, stick around after class. I know that Brianna asked you came in about a minute late, so we'll count you as being here. Anybody else come in?
I was having trouble logging in. I don't know if you got me.
Yeah, I did. I saw that you were having trouble logging in. Your square kept coming up saying you're trying. So we got you. Thanks for making sure of it, though. Anything else I can do for anybody?
Nope.
Nope. All right. Have a good day. We'll see you on Friday.
See ya.
See ya.